what we did here was we put a skewer over here on the glass, and then we burned the skewer. You can see the burnt part of the skewer inside, and we see that it's balanced. The center of gravity laterally is over here. Isn't that crazy? Now, did that seem obvious? That I did not. I still find it an outrageous thing. Halal, don't touch the table, please. Isn't that crazy? Yeah.
Crazy. It's over crazy. Not crazy. Over crazy.
Over crazy. Sure. Don't you think? Yes. So I'm glad that worked. So we're gonna first put some water in.
I'm not for video.
Okay, Aaron.
I don't do events to it.
Okay, so we're putting water in the balloon. Don't put too much.
Okay.
Okay, you put too much.
Too much. Okay, and then we blow it up. I know.
Yeah, we need to blow it up.
Or I'm not like a...
It's hard to tie.
You can even put more
And to
water in.
blow it
It might
up.
help out, but it's hard to get more water in. Should we try putting in more
Yes,
water?
come on.
Okay, you know what? No?
Yes.
Yeah.
Yes. Whatever.
I think
Just don't make it explode.
I think we can do it with straws. Yeah, I think straws will help us to put more water in. Does that make sense?
We initiate 90%.
Okay.
And I don't...
I don't know how we're going to do this. Let's try it like this.
Because I'm now in... more easily. I'm going to have kids
It's working. So weird, but it's working.
I know how to do it. Just like let the water go slowly.
Like yesterday, I called her, I'm like... Because the ladies...
Wow, I have to get it. Me too.
I'm like, no. Those things are good. I think it's 5-6.
Now we have a lot more water in here than we did before, right?
Yes.
Let's put some water in.
Seriously, well, crazy. Yeah, over crazy.
Okay, this was out the flame.
Yeah, million% crazy. Hey, this is also easier to blow, don't you think?
And this was out the window of the
Wow.
airplane. And it was like
Okay.
huge.
Yeah, if it did explode, we have a lot of water to
It was so
mess up the floor. Well, was that creative? Thank you.
Stop it,
Yeah,
stop
I thought of it on the spot. I'm impressed that I actually thought of it.
Okay.
Normally, I would not think of creative things like that. Let's see if I could try it.
It's tied.
Okay, let's try it.
Woo.
Okay.
I can get this.
Okay, you ready? We already did one where it was without water.
Just to make sure everything was okay.
Is that crazy?
Yeah.
It wouldn't have exploded right away before.
Can I see the dot?
Yeah.
Me too.
See the fire mark?
This is the fireball. That's dot.
Now, why did this happen?
Because there's water
The
inside.
water. That's right. What does the water do?
It cools it down. The fire
It cools it down. Well, you would be right if the fire was outside the balloon. But it keeps the temperature of the balloon. See, they're touching each other. So what happens if something really hot touches something very cold? The heat would transfer from the hot place to the cold place until they're both very hot, right? And if they're both very hot, then they'll both be very hot. But in the meantime, they're not both very hot. And we can do it again.
No.
It did explode.
Do not. Can I see the second one?
You made another, yeah, it looks like a smiley
Look, he made a
face.
smiley face. Out of
A
fire.
little bit. Okay, alright, I promise I'll be actually taking off the balloon. Let's turn off the video. Oh, you know. Watch this, Sarah. You ready? Hold on. We're gonna start by doing this. And then we're gonna pull it away. So,
Wow.
isn't that crazy? Now, why is that working?
Because first you stuck it in that.
Well, that's right. The magnet is pulling on the coins, right? And when the magnet pulls on the coins, it's pulling them all up. Well, if they're all being pulled up, can they fall down from each other?
No.
No. Not only that, but this, because don't take the phone too close to the magnet, please.
Okay.
Because this is so close to the magnet, this is now magnetic too, right? Watch. I'll show you that it's magnetic because watch what happens. Oops.
Daddy.
Stop, I'm not talking. This is how you know it's magnetic. Watch. See? Now this is magnetic too. Because the magnetism is going into this, right? And that's exerting some magnetic force on this. Right?
Did you try it up here?
What was that? Yeah. So that's how we're able to do it. And then, if you have some trick photography, like Yitzchak can take the camera. Oops. Yitzchak can take the camera and focus on a particular place that makes it look like they're just balanced without the help of any magnets. Right?
If it's too big, the camera's too big to do that.
Oh, really? Okay. So, well, you can angle it down.
Try it up here.
Hold on.
You can hold it that, yeah.
No, it still doesn't manage.
Okay. Now we're going to pull it down. You could get the cups. The cups don't give away the secret.
Oh, okay, so good. Wait. Got it.
Isn't that great?
Yeah.
Okay. Next experiment.
I have an experiment.
Avia, do you remember in the video we talked about how water wants to stay with itself, right? Now gravity is able to make water not stay with itself if there's enough gravity, right? Alright, you're getting in the way.
There's less gravity.
Right. So there's less. So there's smaller holes. So we have a larger effect of surface tension. And watch what happens. There's still holes, right? Water could go through the holes, but after the first amount of water falls out, it keeps most of the water. It's crazy, I think, because there are holes. You could get water out of here, right? There's water that comes out. When I touch it, I'm getting water out of here. Because the water then sticks to the water on my finger. And the surface tension has the water coming out. You can stick things in between the holes here. Oh, this is too thick. We have a toothpick here. The toothpick we can stick inside. It's got holes, right? And even though it has holes, water isn't coming out. That's because of surface tension. Surface tension is very cool, and it's possible in a future week we'll do more on surface tension. Actually, we're going to do another one on surface tension right now. What would happen if I turn this cup upside down?
Everything would fall down.
Everything would fall out. That's right. Unless we have this little card here on top. Now watch what happens.
Whoa. Amazing.
That's also surface tension.
It's in the book.
Is that that's in the book also? Oh, that's the one that we talked about. That's right. Isn't that crazy? The water, this is a full glass of water. Look at that. Regular water. That's right, Avia. What? So the water is what's keeping this in place, which is what's keeping the water up. It's a little crazy. Like it sounds like circular
I
logic.
think the water will like push it down also,
Right.
but it's not.
Well, there is a force on it down,
Yeah.
but somehow the force that's keeping the card in place is stronger. I mean, it's true. It doesn't make intuitive sense to me, but it's true because we see that it's true. The card is being kept in place by the water, even though the water's pushing down on the card. How is the water pushing down on the card, by the way? It's the gravity, right? Gravity should be pushing it down. But it's staying in place.
Because the air pressure goes up, and the air pressure is stronger than the water.
Cool. Okay. We are going to put some food coloring in the milk. And the milk helps us to see the contrast better. So we're going to put a little bit of food coloring over here. Okay? And we're going to put
I think you should put a little bit more.
some yellow. Thank you. Can you have the green one?
Yeah. Here.
Thank you.
What kind of experiment is it?
Well, we are going to show...
Here, found it.
Yeah.
Here.
Okay. Yitzchak, I'm going to look at it after, okay?
So, yeah.
Okay.
And then blue.
And then blue? Okay, alright, fine. Blue. Blue it is.
We have there's a hole in there.
Actually, that was a good idea, Aaron, to just leave a hole. Okay. All the caps are on well? Okay. Oh, cool. Yeah. Okay. Now we're going to use the soap. We're going to put some soap on a Q-tip. And then whoever wants
want.
Okay. Okay.
Everyone wants. I want. I don't care. I don't care.
I've done it a couple times before.
Yeah.
Me too.
It's cool, right?
Can I do? Hey, so you do care. I can do.
Eeny, meeny, miny, mo. Oh, rock, paper, scissors. Okay, you ready? Hold on. You're gonna touch it to one of the piece of food coloring, and don't leave it for too long. Okay, put it in. Oh no, take it out. Isn't that cool? Right? Now try a different place. Put it anywhere else.
Put in here.
Cool. Does somebody else want this chance?
Me.
No. Let go, please.
Me.
Gabrielle, you'll be next, okay?
Okay. I can be after Gabriel.
Yeah. Wow.
milk.
Why milk? I think because it gives better contrast.
It
You can
does.
see the difference between the colors better.
After
Would you say
Gabriel.
that? Would you say that we use milk in order to show contrast better?
It's white.
Because it would show contrast better. Because it floats on top instead of mixing with the rest. Because we see the contrast better. I assume it... Oh, careful.
Still doing mix. It's not
And it stays on top. If we put it in water, it would mix with all the water.
Now me.
How different are they?
It's still happen?
So that's the question that we need to ask, right? So the soap has an effect on the surface tension. It stopped?
Doesn't have any more soap left.